Today we are discussing the fifth module, that is perspective projection. It is a 3D projection in which you will get the real life view of a particular object. So let's discuss the difference between perspective projection and the other type of projections. So in perspective, as I told you, you will get a real life feeling or how we are observing different things with our human eye. And perspective drawings usually used for drawing large objects like buildings, railway crossings, something like that. And in perspective projections, we'll get the objects or the picture of the objects in a particular picture plane known as a picture plane. It is not a front plane or horizontal plane. So we are watching the objects from a particular point, that is known as station points, and we will discuss the terminologies in the later slides. But let's see one picture of the perspective projection. Here we are drawing a particular picture, and here we can see different apartments. The apartment which is very nearer to the observer is bigger compared to the apartment which is away from the observer, but that is not the actual case. Maybe the height of this apartments are very high compared to this one, but in appearance this one is bigger comparing with the other apartments. This is why, because this apartment is very nearer to the observer, the rays of lights which are passing from the eyes of the observer is not parallel. If I am standing here, the light ray from my eye to the top corner of this building and the corner which is away from my eye level, they are different. The rays are not parallel to each other, they are inclined to some degree with the observer's eye or the ground level, so they are not parallel to each other. That's why we are getting an inclined line like this. So this is one of the example of perspective projection. Let's see other pictures. Here also you can see the difference. So this picture will give you a real-time feeling. If you are drawing a rod in orthographic projection, you will get two parallel lines, because in actually the distance between these two lines, they are constant. If you are drawing a railway crossing or something, or a rail or something like that, the distance between two parallel lines, they are constant. So in orthographic projection you will get a parallel line, but in perspective you will get a picture like this. So that is the difference between perspective and orthographic projections. Now let's compare orthographic projection, isometric projection and perspective projection. See, in orthographic projection we are not marking the position of the observer. Position is at an infinite distance from the object. We know the 4 elements of projection. We need object, observer, a projection plane or picture plane, and rays of light. So this cube is the object. We are placing a picture plane in between the observer and the object, or otherwise you can place the picture plane here away from the object, no problem. And observer is at infinite distance, so there is no need of drawing the position of the observer. He is at infinite distance from the object. If he is infinite distance from the object, the rays of light coming from his eye are parallel to the ground level. So you will get a parallel lines like this. If you are projecting the image to the projection plane or picture plane, you will get a shape like this. So that's why we are getting a constant or a rectangular or correct shape in a picture plane. So you will see one side at a time. So that's why we need front view, top view and side view to get the exact idea of a particular object. Since two axes are visible, if you are placing the picture plane parallel to only one surface, so you will get only one face because the rays of light are parallel. But in isometric projection we are tilting the axis of the object with respect to the picture plane, but still the observer is at infinite distance. Rays of light are parallel to the ground level. But if you are projecting, because of the tilting of the axis, you will get a 3D picture like this. But here all the axes are equally inclined to the reference plane, so you will get a picture like this, but it won't give you a real-time appearance. So you can understand from isometric view that it is a 3D picture, but it won't give you a real-time feeling. But in perspective we need to place, or we need to show the position of the observer. In all other projection like orthographic and isometric projection, you are not drawing the position or marking the position of the observer. So the main difference between perspective projection and other projections are, in perspective projection you have to mark the position of the observer. The observer is looking an object, same object, cube, and we are placing a picture plane in between the observer and the object. To get the images on this projection or picture plane, you have to draw the visual rays of light connecting the eye level of the observer and the corner points. See, these light rays are not parallel, but in orthographic projection and in isometric projection, they are parallel to the ground. But in perspective projection, the rays of light coming from the eyes of the observer is not parallel to the ground plane. So that is the difference between orthographic projection and isometric projection, or sorry, perspective projection and isometric projection. Both are 3D. Isometric projection is a 3D projection, perspective is a 3D projection, but in perspective you have to mark the position of the observer, and the rays of light, they are not parallel. So which means we are marking all the elements of projection in perspective projection. In isometry we are just marking the object, and we are just drawing the picture plane. We are drawing the this 3D picture on the picture plane or projection plane. But in perspective projection you have to mark the position of the object, position of the observer, and you have to draw the rays of light to get the final shape in the picture plane. So that is the difference. As I told you, to get different perspective, you means the observer can move around the object. If I am standing here, I will get a perspective like this. If I am moving, E means eye level of the observer. If observer is watching the object from this side, you will get a picture like this. If the observer is watching the object from the other side, he will get a picture like this. So depending upon the position of the observer, eye level of the observer, you will get a different shapes. So position of the observer is important. Let's see two types of perspective. There are two possibilities. As I told you, you can place the picture plane in between the object and the observer. If you are placing like this, whenever you are trying to project this object to the picture plane, you will get a small shape of the big object here in the picture plane. So here the size of the object, real object, is very high, but you are drawing a small picture. Similarly, if you are placing the object in between the picture plane and the eye level of the observer, in that case, if you are projecting the rays to the projection plane, you will get the enlarged view of that particular object. So there are two different possibilities. You will get a small image or enlarged image depending upon the position of the picture plane. If the picture plane is in between the object and observer, you will get a small sized image. If the picture plane is behind the object, or the object is in between the picture plane and the observer, then you will get an enlarged image. Now let us learn some terminologies associated with the perspective projection. First one is ground plane. Ground plane, this yellow color plane is known as ground plane. Ground plane is the plane in which the observer is resting, or observer is standing, or object is standing. So you have to place the object somewhere or observers somewhere. That plane is known as ground plane. It is something like your HP, horizontal plane, reference plane HP. So what will be the front view of the horizontal plane? It is a straight line. So front view of the ground plane, it is also known as elevation of ground plane, and its abbreviation is EGP. So that will appear like a horizontal line in your final picture. So it's a horizontal line, ground plane. And second plane is horizon plane. See, the observer is watching the object, and if you are drawing a plane parallel to the ground plane, passing through the eye level of the observer, then that imaginary horizontal plane is known as horizon plane. Next plane is known as picture plane. This plane is picture plane. It is a plane in which we are getting the image. It is a vertical plane, and this plane is actually perpendicular to ground plane and horizon plane. You will get the image here in the picture plane, and the top view of the picture plane will appear like a horizontal line. If you are looking from the top, you will get a horizontal line. And next plane is central plane. See the plane perpendicular to both the ground plane and the picture plane. This plane is known as central plane. Central plane will help you to understand whether the object is on the left side of the observer or on the right side of the observer, whether a point on the object is towards left side or right side of the object. So that is known as central plane. It is actually passing through the eye level of the observer, and it is perpendicular to ground plane and picture plane. And last plane is auxiliary ground plane. It is a plane which is parallel to the ground plane, and sometimes to see the object from the top side we need an auxiliary plane. See, you can place the object here in the ground plane and then you can go there. For example, you are watching a person standing on the ground from the first floor of a building. So this is your position. Observer is here at the auxiliary ground plane and object is resting on the ground plane. So it is a plane parallel to the ground plane and some distance away from the ground plane. So that is known as auxiliary ground plane. You can draw infinite number of auxiliary ground planes. You can take down these nodes. Ground plane is a horizontal plane on which the observer is resting or placed. Station point. The eye level of the observer is denoted by station point. So in some textbook it is denoted by E, which means eye. But in our problems we are representing this point by capital S because that is a single point, station point, and its front view is denoted by S dash and top view is denoted by small letter s, because in 3D or in any projection, in orthographic projection, you learned how to express a single point. The front view of that point is A dash, top view is small letter a. Similarly, front view of capital S, station point is S dash, top view is small letter s. Next one is picture plane. Picture plane is a plane on which you are getting the image or perspective. So this is a vertical plane, something like you are a VP. You will get the image on or perspective on the picture plane. And ground line, you know what is a ground line. That's a front line, intersection of picture plane and the ground plane, something like XY line. It's a horizontal line. And horizon plane, a plane parallel to the ground plane. And the horizontal line, you know the horizontal line, the intersection of horizon plane with a picture plane. And visual rays, you have to draw the visual rays connecting the object and the station points. And we will solve problem using visual ray method.